5 using chain rule. So here's the last formula for taking derivatives. And these are for more complicated equations. So when I have functions inside functions, well, I take the derivative of the outside function, leave the inside function alone, and then times that by the derivative of the inside function. So this gets really complicated when you have a function inside a function that's inside another function. So this function inside the function of g inside the function of f. So that I take the derivative outside, well, I'm going to need some more room to write this. That would be f prime, leave the inside alone, then times that by the inside derivative, the derivative inside, and then I got to times that by the derivative inside of that, which is the derivative of h. So basically, it's derivative of the inside times the derivative of the outside of that function times by the derivative of the outside function. So it's a lot of derivatives. And then when we add product rule and chain product rule in there, then or quotient rule, it becomes really hard. So here we have a function 3x plus 2 and it's being raised to a power. So that's a function inside a function. So we take the derivative outside times that by the derivative inside. So there's 12. These ones are the easy ones. Anything with a function raised to a power or even a root. If this was the root, we could rewrite that as a half power. And so those ones are actually not bad. So those ones are not bad. So hopefully you're not scared by those ones, because then it's going to get really scary when we add product in there, because there's product right here. So this is f and this is g. So f prime times g plus g prime times f. So I got to take f and I got to take the derivative of that. So that's kind of like the one we just got done doing. Drop the power. Multiply by the derivative of the inside, which is 2, so that's not bad. Just 10 times 2x plus 1, and 2x plus 1 is being raised to the 4th. G, which taking the derivative of this is not too bad either. Or is that to the 4th? That's to the 4th. Because we move the power out front. Drop the power, and times out by the derivative of the inside, which is 3x squared minus 1. Okay, so that's g prime. Now I got to apply product rule. I got to apply this. So I got to take the derivative of f, times it by g, and then take g prime and times it by f. And then you got to simplify, because sometimes the back of the book simplifies it more than you would like to simplify it. So when you check your answer, you don't think you're right because you didn't simplify it far enough. So there's f prime, right? F prime. Got to times that by g to the 4th, which is g. Now I got to move that over because I need a lot of room here. And then I got to add the derivative of g, which I got to write really small because it gets really long. And I got to times that by f, right? So basically I have two terms here. I have this whole term and this whole term, so I look for common factors. So I have this factor on both sides, right? And the most I can take out is to the 4th. So that means these, I take that out. And then the other factor that I have is this one, because they're both on the same. And the most I can take out is cubed. So these will be all gone. So then I have x cubed. So this is what I'm taking out. I probably should have wrote it smaller, to the 3rd. Okay, so that means these are going to be all gone. These are going to be all gone. So then I have 10, and then 3 of these are gone, right? because this is to the third, so 3 of them are gone, so I'm left with just 1. So 10 times that is 10x cubed minus 10x plus 10. And then I took out 4 here, so 4 of these are gone, so I'm left with that. So that's 4 times, multiply this, FOIL this out, I can FOIL that out, which is 6x cubed plus 3x squared minus 2x minus 1. Okay. Hey, I actually kind of almost made it. All right, now I can distribute that 4. Okay, so I can distribute that 4. That becomes 24. That becomes 12. That becomes negative 8. And that one becomes negative 4. So I got 24x cubed and 10x cubed. That's a 34x cubed. And then I got negative 10x and a negative 8x. So that's a negative 18x. But I'll put my squared before that, sorry. So 34x cubed. Let's see, this is an x squared, 12x squared, so plus 12x squared. Then a negative 8x and a 10 negative 10x is negative 18x. And then I have a 10 and a negative 4, because that was a 1 right here. It's a negative 1. So that's a positive 6. So there we go, we fit it right in there. I didn't even have to put it that way out there. So this is probably what the back of the book has. It might have a step up here maybe, or maybe way up here. Usually it wants you to factor these common factors out. So it wants something like this. So it might have this in the back of the book. Just depends on how far the authors wanted to go. And then it might have whatever we took out was left. What was 10x cubed minus x plus 1 plus 4. And then these two, 3x squared minus 1 times minus 1 times 2x plus 1. So it might have that in the back of the book, or it might FOIL those out and reduce it to that. So it gets complicated. Then we have quotient rule, right, which is f prime times g minus g prime times f all over g squared. So we got to take the derivative of the outside, which is a function being raised to a power, so that's 9 times x minus 2 over 2x minus 1. Okay, so that's the derivative of the inside. Got to drop a power. So that's the derivative of the outside. Now I got to take the derivative of the inside, and the derivative of the inside is quotient rule. So that's f prime. So f prime is taking the derivative of f, which is just 1, times that by the bottom, minus the derivative of the bottom, which is just 2, times the top, all over the bottom squared. Okay. Now I can start simplifying. This is just 2x minus 1. This is just negative 2x plus 4, sorry. Distribute the 2, or negative 2 to both of those. So then we get all over 2x minus 1 squared. So then this is 3 over 2x minus 1 squared, and then times the x minus 1 all over 2x minus 1. Is that what the minus 2 on top? And then 9 out front. So it could be left like that. They're not going to mess with anything above power of 2. They're not going to FOIL it out. So anything to the 8, they're not going to multiply it out. And you don't have to look for common factors here because this is multiplication in between here. So maybe what they did is just probably multiply these two numbers because this is in the numerator times 9. So we get 27, x minus 2 over 2x minus 1 to the 8th times by 1 over squared. So they're not going to FOIL this out squared unless it will cancel with something. So they're probably going to leave it something like that in the book, and they might even do something, maybe at the back of the book has something like this. I don't know. Maybe it has something like this. Maybe it has something like this. Maybe they left it out like this. Right, it's just trying to the back of the book probably simplifies the most possible. So maybe raising something to the 8th power is bringing the top to the 8th power, and then bringing the bottom to the 8th power. So why they probably go this far, 27 on top. And when I'm dividing, I'll come back to this one, where dividing by something is multiplying by 1 over that. So why they probably go this far is because these are the same two factors. And now when I multiply the same base, I add exponents. So this is probably what they actually have in the back of the book, because that's as far, because we can combine these two factors right here to 10 on bottom. So that's probably why they go this far, because anytime you have same factors and you're multiplying, you add exponents. So here it looked like I couldn't do anything because I had multiplication here, and this was being raised to the 8th, so I wasn't going to FOIL that out or anything. But because these were the two same factors on bottom, I could go farther than that, and I used my exponent rule to take that 8 to both of them. So the back of the book probably has that one right there. All right, chain inside a chain inside a chain inside a chain. It's just a big old chain link. Okay, so I take the derivative of the outside, the derivative of sine, which is cosine. So the derivative of sine is cosine. And then I'll have to times that by the derivative of the inside, which is taking the derivative of cosine, which is negative sine. And then because this is this right here, so the inside is a chain rule on itself, because that is a function inside a function, right? A function inside a function. So I'll have to take the derivative of tangent as well. And the derivative of tangent is secant squared. Okay, so we take the derivative of the outside, which is taking the derivative of sine, which is cosine. We leave the inside alone, and then we times that by the derivative of the inside, which I'll have to move this over. Okay, now the derivative of the inside is a chain rule on itself, because I have a function inside a function. So that's the derivative of cosine, which is negative sine. Evaluate at the inside, so I leave tangent in there. And now I take the derivative of the inside, which is secant squared. So I times it by secant squared x. Okay. So that's how the answer looks. In the back of the book, they probably maybe move this negative out in front, because it's a positive times a negative times a positive. So they probably put the negative out in front like this. So that's probably how the back of the book has it. All right, so that's how complicated you can get, and it probably can get more complicated than that, because I could just take this, could just be cosecant x.